Hello everybody, this is another video about generative artificial intelligence with synthetic data fold. In the first one we use the conditional tabular generative adversarial network as algorithm. In this one we will use the GaussianCopula algorithm to augment spatial data. So the number is going to be the same. We have in the original file 200 rows. We are going to augment to 400 rows. And of course we need a geodata frame with a geometry column and non-spatial data for this purpose. So let's go to Jupyter Notebook and start working. So you need to install the libraries and importing them. So we need the pandas, GeoPandas. We need our SDV, synthetic data fold, and the plotting libraries as well, matplotlib and NB format in case you have error messages thrown up when you run the fig.show. So after the installations you import them with pandas as PD, import numpy as NP, import GeoPandas as GPD. You need to import point for coordinates for the spatial data, and this is the algorithm itself from from SDV.single table. You need to import GaussianCopula synthesizer. Before it was CTGAN synthesizer, now GaussianCopula synthesizer. You need the single table metadata and the metadata from SDV.metadata, and for the graphics as well. If you have a error message thrown to you, you import warnings and type warnings.filter warnings, ignore. So this is the data we used before. We load it by typing pandas.read_csv, and this is the directory where your data is found. This is the name of the data set. So let's see the shape of the data set. Data.shape gives us the number of rows and number of columns. So 200 rows, 3 columns. And if you want to see the columns, data.columns, these are the columns. You have x coordinate, y coordinates. These are spatial. The PH is non-spatial, but we specialize in this case. So data.head gives us something in row and columns with the first 5 rows. Now we need the geodata frame, as I said. Sorry. Okay. Transforming into geodata frame, Okay. The data pandas, so we need to set the geometry. Setting the geometry. geometry equal, okay, let me run everything here first. Okay. Equal to point with capital P, just brackets here, and then parenthesis xy, the coordinates for xy in zip parenthesis data, the object dot x code, and then data comma data dot y code. And we close the parenthesis, then the bracket. That's the geometry. And then the data frame, from data frame to geodata frame. To geodata frame. Let's call it the real data, the name of the geodata frame. Our real data equal to GPD, geopanas, data frame dot geo data frame with capital G, D, and F. Our data frame, which is data. Then the geometry, which is the geometry you just set above. And then the coordinate reference system, which is equal to the EPSG 4326. Depending on your area, may be different. Good. Run. Now let's explore it a little bit, our geodata frame. Real data dot shape. Okay, let's print both of them. Print data dot shape and the real data dot shape. So you have 200 as rows with 3 columns here in the data, and in our real data geodata frame you have 4 rows, which means we have added the geometry. We are going to see the columns. Print data dot columns and the real data dot columns. So this is the real data. This is the data start here, and the real data we have the geometry column, which is added here. Okay. Let's print data dot heads. That's for data. Let's try real data dot heads. Okay, we have geometry, but that's not very good to see. It's not clear. Let's have it down here. We have geometry added here with points. In comparison, we have the coordinate for each location here. Point. And the geodata frame, this is needed. The geometry is needed to multiply the geospatial data. Okay, now we go to the data augmentation itself using GaussianCopula synthesizer. Let me put here. Synthesizer is the algorithm. Okay. To do this, we first need metadata. Metadata from our real data. Metadata equal to metadata dot detect from data frame real data. Metadata dot detect from data frame. So we already got our metadata. Now we need to initialize and train the model. So let's call it Gaussian model. Before we call it model, Gaussian model equal to GaussianCopula synthesizer metadata. The model for GaussianCopula synthesizer metadata. Okay, you already have it, so now let's fit the model on the real data. Model that fit. Real data. Good. This time it went quickly. Metadata on real data. The model is metadata fitting the model on real data. Now we are going to generate the synthetic data. So call it synthetic data equal to G model dot sample number of rows 400, name rows equal to 400. So go from 200 to 400 rows, row augment. For data augmentation. Okay. What is wrong with this? Synthetizer not fit. Okay. This is G model here. Instead of models, G model dot fit. Sorry about that. Okay. Now we need to integrate with geometry. We generate the data, but we now need it in geodata frame. So integrating the data with geometry. Go back to it. So let's call it again sampled geometry. This is our geometry we need. Sample geometry equal to real data dot sampled n equal to goes to the length of the synthetic data and then replace equal to true. Random state equal 42. Close the parenthesis. And then we need the geometry. Code and the bracket, and then reset underscore index and parenthesis drop equal to true. Okay, let's run the code. So this is the sample geometry, so new geometry we need, and then we take the geometry from the real data basically, and we sample it with the synthetic data. Okay. we are going to create the final augmented geodata frame. So let's call it again. That's a new synthetic data. Equal to GPD geodata frame. Synthetic data, our old one. Means this one is the old one. This is the new one as GPD. This is the one generated from the real data. So geometry equal to sampled geometry and CRS equal to EPSD 4326. Good. Now let's explore it. Synthetic data dot head and shape and see. Data dot shape. And synthetic data dot head. Our geometry here as a geodata frame. Now let's save it. To a comma separated value. Synthetic data. Synthetic underscore data point to underscore comma separated value parenthesis quote, let's call it GenAI dash GaussianCopula data dot comma separated value, close the quotes of parenthesis. We run it. Good. Let's go to your C drive. Have users, and wherever your Jupyter notebook or your Anaconda is installed, that's where I have all here, the Jupyter, Anaconda, everything. So let's seek for our synthetic data. GenAI, that's here, today 28th, so let's open it, February 28th. compilation slow. So here we have x coordinate, y coordinate, pH geometry. That's the 4 rows, 4 columns or variables, and we have here 400 rows. So if we go to, let's see the name of the data set, Wells SDV. You go here in E. The data. Should be in E, sorry. The data. Special data. Yes, this is well SDV below here. It's the original data. Sorry, my machine is super slow now. I have to change it. So you have here, this is the original data. You have x coordinate, y coordinate, and a pH. These are the 3 variables, and we have here just 200 rows. So the difference. This is the original, the other is the augmented data. Okay, so let's come back and continue. Now we are going to evaluate the real versus synthetic data. Evaluation of real versus synthetic data. Real and synthetic data. So from SDV.evaluation.single-table, SDV.evaluation.single_table, we need to import run diagnostic. Run_diagnostic. Then we have the diagnostic as object here, equal run diagnostic parenthesis real data equal real data make synthetic data equal synthetic data metadata equal to metadata. So the report 100% on the validity of the evaluation, overall score 100%. That's well performed. Now we are going to assess the measure of the statistic similarity. statistical similarity. Between the real and synthetic data. We need evaluate quality from from SDV dot evaluation dot single underscore table import evaluate quality evaluate underscore quality. Then quality report equal evaluate quality real data synthetic data and metadata. So column shape score 78%. That's column per trends score 15%. Overall score average 46.66%. That's below 50. So that's not good for this data. You need probably to increase the size. Let's see whether the score will increase. But yeah, that's the way to do it. But depending on your data, the result here, the results are going to be different. To get the quality report detail, quality report details, quality report dot get quality underscore report dot get underscore details parenthesis quote column capital C and the shape with capital S, shapes plural. Close the parenthesis. Okay, next one will be coordinate pH and geometry with the metrics and scores. If it's necessary for you to interpret the data and use it. So now the visualization. Step visualization of real versus synthetic data. So from SDV, let's have separately in 1D and 2Ds plots say on the plot. We are going to take pH. That's the only variable we have here. So from SDV dot evaluation dot single table import get column plot. Then fig or figure, the object is equal to get column plot, get column plot. Oh, sorry. Not done yet. Get column plot. Now real data equal real data. Data, synthetic data equals synthetic data. Column name equal to pH. Column name equal H, capital H, lower P, upper H, in quotes, in the metadata equal metadata. Metadata and the figure dot show moving on. Okay, so you have real data, synthetic data, real data here. This our synthetic data, and we see how they are close or not, graphical or pictorial view. These are the values. The synthetic data, the real data start from 6 to around 9 up to here. The synthetic data start at 6.5. Okay, and goes up. That's almost similar frequency. The frequencies are not the same. That's for synthetic data. For real data is below. Okay, that's how you explore, and then let's have the 2D plot. Compare the correlation as pH and the longitude. So X column here. So for this we need the get column pair plot from SDV dot evaluation dot single underscore table, import, get column pair plot. And then we have our object fig equal function get column pair underscore plot parenthesis. And here we have real data equal real data. Make synthetic data equal synthetic data. Comma column names equal, we have bracket, we have quote, lower p, upper h, comma, and x coordinate in quote as well. This is the longitude. Then we close the quote, comma, and metadata equal to metadata. Then out of the parentheses we have fig.show. Okay, so we have x coordinate here, the longitude on y-axis and the pH on x-axis here. You see the distribution of the real and the synthetic. Real, synthetic, you compare the two here. 8.1 and here 8.7, another synthetic 7.98, so on, the 200 data and 400 data. If you want to see the distribution along the latitude, so you just copy this, you paste it here, latitude, you change longitude by latitude, and the x coordinate by y coordinate, and you run. Real data, synthetic data, you have the latitude here, and the pH on x-axis. I'm analyzing, but you see yours might be different. So synthetic data, they go, yeah, that's 2 minutes here. And here, they spread real data to few, only around 8, 9, while you have many of the synthetic data. Up to 9 here. You see this. Oh, you see the data points for real data is about only, that's 6 to 4, 6. That's 6 only here. But for real data, there are too many. Yeah. So it generates more data for you where there are not. Okay. So saving the model. So we call it gmodel. So gmodel dot save. No, gmodel. Parenthesis quote my G model. So my G model dot pkl. Where's the parenthesis? Okay. And you will find it in wherever your Anaconda is. So where you have Jupyter installed, that's where you find everything you run here. See it from here. Okay, so to load it, if you want it to continue, so from SDV dot utils import load synthesizer. Load underscore synthesizer. And then we have model equal load synthesizer. Parenthesis code my G underscore model. Dot pkn. So you want to continue with it, so model dot sample. You go again with number of rows equal 400. And you see here 400 rows, 4 columns. Let's coordinate y coordinate pH geometry. Okay, now this is what we have, and we need to customize it sometimes to see, but let's do it here to see the improvement, whether there is or not, as we did it for the GT gun. So Gaussian Copula synthesizer customization. So we need to create a custom model first. Customize model. Let's call it custom underscore model equal to GaussianCopula. Synthesizer. In parentheses, sorry. We have default distribution. The metadata first. Default distribution. Equal to quote trunk norm, comma, then numerical distributions, equal to curly brackets. Here we have pH. That's uniform distribution. Uniform. Have x coordinate. Also set to uniform. And the y coordinate also set to uniform. Then curly bracket closed, also parenthesis closed. So this our customized model. Now we are going to fit the customized model. Using the real data. So custom model dot fit real data. It's already run. Okay, now we are going to evaluate the customized model to see the improvement. Okay. Synthetic data. So for this you need to create synthetic data customized as well. Synthetic data underscore customized. This is equal to custom model dot sample num rows 400. Okay, synthetic data customized equal custom model dot sample num rows 400. So have a custom model fit on the real data. We need synthetic data corresponding to it, so customize. Okay, now that we have this, the quality report evaluation of the synthetic, the synthetic data customized. So quality report evaluation. The synthetic data customized. So quality report, we already imported the wallet quality, so you don't need to do it here. Again, quality report equal evaluate quality. Parenthesis. We have real data. Equal real data synthetic data customized. Synthetic data customized, and you have metadata. Is there any improvement? I don't think. We had 46, now it's 36, no, 37. Per trend it was around 72, so here 62, 15. Let's check here in the C. Yeah, there is no improvement, so 72, 78. When we customize 62, here 15, 12 down there, here 46, 37 down there. So the customize does not improve the model, so we just keep with the original one. Okay, now if you want to verify using the visualization function, just fig equal to get column plot real data equal to real data. Synthetic data equal to synthetic data customized. data column name ph column name ph, then metadata, equal to metadata. This here we need comma, yeah. And then fig.show, you see here, this is from the customize, and this is from the real data. This is synthetic data from the customized model. Let's go up and compare to the normal model. Just by looking at the shapes, you see here this one is better. Synthetic data here is closer to the real data than the one below. When you customize it, okay, thank you very much. We are at the end of the video, so thank you very much for watching it, and I hope it will help some people who are doing their research. The main idea is here to generate more data than what you have and assess the quality of the data you have after augmenting it, because having more data is important for some people who have very few data from their area of study and they need more. So the generative AI is a kind of solution to that. You have 100 data, you add more by using GenAI, and there are methods for geospatial data. There is a new method will come to that probably using GeoAI. Here we use SDV, synthetic data role, with two different algorithms, SDV-GaussianCopula and GaussianCopula. There is a more specialized method using GeoAI, so artificial intelligence for geospatial data. So going through a geodata frame is a mandatory step here, it's needed. So yeah, but it's important. I use this one for my research and I got some data from it. It's good. I compare the two. I use the two different algorithms here, SDV-GaussianCopula and the GaussianCopula. And the GaussianCopula gave me more accurate, a higher overall score than the GT-GAN, because I am dealing with the ground truth data. So the distribution of ground truth data is normal. So the Gaussian distribution, we know it's normal distribution. So it helps me. So I compare the two and I took the data generated by GaussianCopula to the next step for my research. So I hope it will help some people who are doing kind of something like me. Okay, so thank you. See you next time for another video.